A sound source emitting a sound of constant frequency moves with a constant speed and crosses a stationary observer. The frequency n of sound heard by the observer is plotted against time t. Which of the following graphs represents the correct variation? Let us say that at time t1 is equal to 0, some wave is emitted by the source, and then some time later at time t2 is equal to dt, another wave is emitted by the source. The number of waves emitted would be equal to n dt in between these two time intervals. Now at t3, the sound that is first emitted by the source would reach the observer. And how long would that take? If the distance between the observer and the source is d and the speed of sound is a, then it would take d by a time interval to reach the observer. Similarly, at t4 is equal to dt plus d minus v dt divided by a, the final sound waves would reach the observer. Why is there a delay that is shorter than the previous case? Because some distance has been reduced between the source and the observer. So now we have in a time difference delta t of dt into 1 minus v by a, the observer hears n dt sound waves, and hence the frequency that the observer notices would be equal to n by delta t, which is equal to frequency, that is the actual frequency, into dt divided by dt into a minus v divided by a, or a into n divided by a minus v. Now we can see that when everything is constant, the observed frequency does not depend on the distance, but it only depends on what is the velocity between the source and the observer. Therefore, it would have a sudden jump as shown in option D, because at one point of time, let us say at this point of time, the source is moving towards the observer and it immediately switches direction, and therefore the sign of V changes. So we would have a sudden jump, which is shown in option D.